Hello everyone, I am Pankaj Kumar Swarnakar, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Welcome you all to the course Essential of Surveying, Application and Techniques. In this lecture, we will focus on calculation of area with the following key points. Introduction for the calculation of area in surveying, various methods of area calculation which are from field notes, using mid-ordinate rule, using average ordinate rule, using trapezoidal rule and using Simpson rule. Also in this lecture we are going to solve numerical problem based on above rules. In the introduction part we will discuss about the area calculation. So what is area in the surveying which we are going to deal? So in the surveying, area is the size of a piece of land as viewed on a flat horizontal plane, not its actual surface area. Why? Because the actual surface area will be much higher than the area on the horizontal plane. Let us assume there is a farmland, so there will be lot of undulation. If we consider area of those undulation, the area will be very high. So we are not interested to calculate that particular area. We are interested in the area which is obtained in the top view of the land between the boundaries. In the metric system, the common units of area we generally used are square meter, square decameter, hectare. What is a square meter? Square meter is nothing but area of a square with sides of 1 meter each. You can see in this figure, this is a square, each side length is 1 meter. So area occupied by this square will be equal to 1 square meter. Then square decameter. Square decameter is area of a square with side length of 10 meter each. Then hectare. Hectare is area of a land equal to 100 square decameter, or we can say 10,000 square meter. Generally, agriculture land is measured in hectare, while urban properties are measured in square meter or square feet. Now we will discuss about FPS system. What is FPS system? Foot pound second system of units. So in FPS system, what are common units of area? So the important units are square foot and acre. So how we can define a square foot? So it is the area of a square with sides of 1 foot each. And what is the acre, which is a very popular unit? Acre is the area of the land equal to 43,560 square feet. Now we will discuss about the determination of area, which is our interest in this particular lecture. Depending upon the topography of the terrain and the required accuracy, the area of land portion may be determined by the following methods. One is from the field notes and the second one is from the plotted plan or map. So how area can be determined by the field notes? When any surveying work is done, field notes is very essential part of surveying work which is prepared. So whenever the area of the plot of the land is determined directly from the field notes, it should be ensured that survey line include the whole area. Means the area which is enclosed by the survey line will be in the shape of polygon and will be having a regular shape. So this area of the land is divided into geometrical figures such as triangles, square, rectangles, etc. In case of triangles, base and height of the triangle should also be measured in the field. Why base and height should be measured? So that during the calculation of the area, we can easily calculate the area of the triangle using the formula half into base into height. The area of geometrical figures is calculated from the following formula. We are going to revise some basic formula for calculation of area which we have gone through in our school studies. The first one is area of triangle. This is very well known equation. area of triangle is equal to root over s into s minus a into s minus b into s minus c. What is ABC? ABC are sides of the triangle. And what is S? S is nothing but half of the perimeter, means A plus B plus C by 2. What is the other way of calculation of area of triangle? If the base width of the triangle and height of the triangle is known to us, then we can easily calculate the area of the triangle using the formula half into base into height. That is why I told earlier, during the survey work, while dealing with triangles, base and height of the triangle should also be measured so that area can be calculated easily. Now you know that B is the base and H is the height of the triangle. Now, how we will calculate the area of a square? Area of a square is nothing but square of the side or A square. A is the side of the square. What is the formula for area of rectangle? It is A into B. A and B are sides of rectangle. What is the formula for area of trapezium? So, formula for area of trapezium is half A into B into D, where A and B are its parallel sides and D is the perpendicular distance between the parallel side. You know that in a trapezium there are two parallel sides. So, A and B are length of those parallel sides, as you can see in this particular figure. Now, we will discuss in the continuation to area of geometrical figures, we will discuss calculation of area between the survey line and the boundaries. Area between the survey line can be calculated using geometrical figure and formula. Why we are able to calculate it? Because generally during the survey work, this survey line forms a polygon and we can easily divide the polygon into triangle, rectangles. But in actual practice, the area between the survey line and boundary, this area will be an irregular shaped area and calculation of this area will be a challenging task. I think you are able to see this particular figure. The boundary you are able to see, boundary is a curved boundary and our survey line is a straight line. So, calculating the area between the survey line and the curved boundary will be a challenging task, and for which we are going to discuss some methodology. In general, the boundary has the irregular shape. So, it will require some kind of idealization of the sides for the approximate area calculation, because if we go for exact area calculation, it will be computationally tedious and time consuming. So, we can approximate the curved part of the boundary using some consideration like straight line or curvature of known order, so that we can utilize our basic formula for calculation of area and it has a good amount of accuracy. So, how we idealize the curved boundary into trapezoid or the parabola, we are going to discuss in detail. For the calculation of area between boundaries and the survey line, the one important challenge is drawing the offset. What is the offset? Offset is perpendicular distance from survey line to the boundary line. So, for calculating area between the survey line and irregular boundary, we have to draw number of offset at a regular interval, and this number of offset are represented by O in this particular figure. Now, what we have done? So, we have divided the complete irregular area into a small areas between the offsets. So, area of the belt bounded by adjacent offset means any two consecutive offsets, area between boundary line and the baseline in between two consecutive offset may be assumed as trapezium and their area can be computed using geometrical formula. The area is calculated by multiplying the mean length of each successive pair of adjacent offset by the distance between them, and this is the formula we have gone through for trapezoid. Let us assume O1 is the offset length at a distance x1 from A along the AC. O2 is the offset length at a distance x2 from A along AC. So, what will be the mean offset length? Mean offset length will be O1 plus O2 by 2, and the distance between two offset is x2 minus x1. So, area of trapezium which is formed by these two consecutive offset will be equal to O1 plus O2 by 2 into x2 minus x1. So, the area enclosed between a straight line drawn on the plan and an irregular boundary line may be determined by following step. What is the first step? Divide the baseline into the suitable number of equal parts. Second is draw the ordinates. Ordinates means offsets at each of the points of division. Then the required area between the baseline and the boundary line may be calculated by any one of the following method. First method is the mid ordinate rule. Second method is average ordinate rule. Third method is trapezoidal rule, and the fourth method is Simpson rule. As discussed earlier, since the area between baseline and boundary line is irregular, so we are supposed to do some kind of idealization. Idealization means we will consider curved portion as a straight portion or any known curvature portion like parabola. So, we are going to do such kind of idealization. So, in the first three rules, what are first three rules? Mid ordinate, average ordinate and trapezoidal. It is assumed that portion of the boundary between the ends of the ordinate means offset. So, portion of the boundary between ends of the ordinate or offsets are straight line. You can see in this figure that curved portion is idealized as straight line. But in fourth method, which is the Simpson rule, it is assumed that portions are parabolic arc, and so because of considering parabolic variation, Simpson rule is also known as parabolic rule. Now we will discuss mid ordinate rule. In this rule, firstly line AB is drawn to some scale on the sheet. Since we are going to do the calculation of the area on the paper, so first we will draw the baseline AB on the paper with some scale. Scale we have discussed in the second lecture. Then this baseline AB is divided into number of equal parts or division. N, the ordinates or offsets are drawn at the midpoint of each part. This is the beauty of this particular rule. The ordinates and offsets are drawn at the midpoint of each division, not at the division point, which is in the case for the remaining methods. So, again I will repeat, the baseline AB is divided into number of equal parts and ordinates are drawn at midpoint of each part. The length of each ordinate will be scaled off using the same scale AB has been drawn. Okay. So, you can see this figure. You should note this point that ordinate is also known as offset. And what is offset? It is perpendicular distance from the survey line to the boundary line. Okay. Now, what is H1, H2 up to Hn? It is the scaled length of the ordinates or offset at the midpoint of each division. Again, you should focus here that ordinates or offsets are calculated at the midpoint of the divisions. Okay. For the later methods which we are going to discuss, it will be calculated at the division points only. But here the offsets are calculated at the midpoint. This is the beauty of this method. For the calculation of area of the plot, we can calculate area of the individual division, and then by adding the area of the individual divisions, we will get the complete area of the plot. So, what will be the area of the first division? The area of the first division will be the mid ordinate value, which is h1, into the distance between offset, which is d. So, area of the first part will be h1 into d. Likely area of second part will be h2 into d. Area of third part will be h3 into d, up to means area of the last part, which is nth part, will be hn into d. So, this all area will be summed so that we can get the total area. So, the area of the plot will be h1 into d plus h2 into d plus h3 into d plus up to hn into d. If we take d common, it will come out as h1 plus h2 plus h3 plus up to hn, the whole multiplied by d. So, now we can understand that area is sum of mid ordinates multiplied by the common distance d. Now, the next method, which is average ordinate rule. In this particular method, a baseline is drawn on the plan dividing area in approximately two equal parts. Here the baseline is shown as AB. Now, this baseline is divided into some number of equal division. Now, you have to focus at this point that ordinates are drawn at the point of division, whereas in earlier case ordinates or offset were drawn at the center of division. Here ordinates are not calculated at the center of division. In the average ordinate rule, we have to calculate ordinates at the points of division. So, we can get these ordinates. So, let h1, h2, h3 up to hn be the length of ordinates. Small d is distance between adjacent ordinates. Ordinate is nothing but offset. Capital L is length of the baseline AB. Small n is number of equal parts in which baseline AB is divided. In this particular method, it is assumed that entire area is made equal to the rectangle whose length is equal to baseline and breadth is equal to average of all the ordinates. So, the area will be average ordinate into length of the baseline. Length of the baseline is L. How we will get the average ordinate? It will be sum of ordinate divided by number of ordinate. So, area will be equal to sum of ordinate divided by number of ordinate into length of the baseline. So, you can see sum of ordinate is h0 plus h1 plus h2 up to hn. Number of ordinate is n plus 1 in this figure. Now, the third method is trapezoidal rule. In this method, a baseline AB is drawn and it is divided into equal parts like we have done earlier. The ordinates at each point of divisions are also drawn, same as average ordinate rule, and the length of the ordinates are scaled off. This method assumes that area between the adjacent offset is of the shape of a trapezoid, and we know how to calculate the area of a trapezoid. So, this concept we are going to use here. Let us assume h1, h2, h3 up to hn be the length of the offsets or ordinates. Small d is the distance between adjacent ordinates. Capital L is length of the baseline. Small n is number of divisions in which baseline is divided. Now, we will discuss derivation of trapezoidal formula. What is the assumption of this? The assumption in trapezoidal formula is ends of the ordinates are joined by a straight line. Thus, the area between baseline and the irregular boundary is divided into series of trapezoid whose parallel sides are equidistant. Parallel side, what is the parallel side in this case? Offsets are the parallel side. In trapezoid, two sides are parallel, as you can see in this figure. In our case, parallel sides are nothing but ordinates or offsets. Let us assume h1, h2, h3 up to hn be the length of the offset at equal interval, and small d is the distance between adjacent ordinates or offsets, means spacing of offset is small d. Now, the area of a trapezoid, we know that what is the area of a trapezoid? It is the half of the sum of the parallel side into the perpendicular distance between them. So, how we will calculate area of first trapezoid? It will be equal to h1 plus h2 by 2 whole multiplied by d. Similarly, area of second trapezoid will be h2 plus h3 by 2 into d. Area of third trapezoid will be h3 plus h4 by 2 into d. Similarly, the area of last trapezoid will be hn minus 1 plus hn by 2 into d. So, you can see now the total area will be summation of all small trapezoidal areas. So, we can do the summation. So, we will get area is equal to d by 2 in the bracket h1 plus h2 plus h2 plus h3 plus h3 plus h4 plus up to hn minus 1 plus hn. If you carefully see this equation, only h1 and hn appear once, rest of the term appears twice, means rest of the terms means h2 to hn minus 1. So, we can simplify this equation as a is equal to d by 2 h1 plus 2h2 plus 2h3 plus 2h4 plus up to 2hn minus 1 plus hn. So, we can write area is equal to d by 2 into, in the bracket, first offset plus last offset plus 2 into sum of remaining offset. In the statement form, we can say to the sum of first and last ordinate add twice the sum of remaining ordinate and multiply the total sum by the common distance between the offset. Half of the product equal to the required area. The last and very important one is Simpson rule. In this method, a baseline is drawn and divided into portion of equal length, like we have done earlier also. At each point of division, ordinates are drawn and their length are scaled off using the same scale which is used for baseline. The area of the portion bounded by baseline and the irregular boundary is calculated by Simpson rule, which is stated below like this. To the sum of first and last ordinate add twice the sum of remaining odd ordinates and 4 times the sum of remaining even ordinates. Multiply the total sum by 1/3 the common distance between the ordinates. The result give the required area. Mathematically, we can write area is equal to distance between the ordinate, which is d, d by 3 multiplied by, in the bracket, h1 plus hn plus 2 into sum of the remaining odd ordinate plus 4 into sum of the remaining even ordinate. So, what is the sum of the remaining odd ordinate? It is h3 plus h5 plus h7 up to so on. What is the sum of remaining even ordinate? It is h2 plus h4 plus h6 up to so on. Now, while using the Simpson rule, some points should be noted. The Simpson rule is applicable only if number of ordinates is odd. If the number of ordinates is even, the area of last two offset can be calculated by trapezoidal formula separately, and this area will be added to the result obtained by applying the Simpson rule to the remaining parts of the baseline. Now, the basic assumption in the derivation of Simpson formula is that the portion of irregular boundary between the ordinates are assumed as arc of parabola. You can see in this figure concave and convex parabola shape is assumed. Now, if we talk about comparison of accuracies achieved by Simpson rule and trapezoidal rule, the results obtained by using Simpson rule are more accurate as compared to those obtained by trapezoidal rule. Hence, Simpson rule is invariably used when better accuracy is required. Result obtained by using the Simpson rule are greater or lesser than those obtained by using trapezoidal rule. According to the curve of the boundary is concave or convex, means there is no such foundation that Simpson rule will give higher result than the trapezoidal rule. It may give higher result, it may give lower result based on the nature of the curve. Let's see this numerical example. The following perpendicular offsets were taken at 10 meter interval from a survey line AB to an irregular boundary line. What are the offset length? 2.3, 3.8, 4.55, 4.75, 5.25, 7.3, 8.95, 8.25 and 5.5 meter. Calculate the area in square meter enclosed between the survey line and the irregular boundary. The first and last offset by application of Simpson rule, trapezoidal rule and average ordinate rule. So, if we draw a figure based on the offset given, the figure will look like this, and the common distance between the offset given is 10 meter, because it is written no, the following perpendicular offset were taken at 10 meter interval. Now, this figure shows the offsets and their spacing. Now, we know the formula of the Simpson rule. So, it is A equal to D by 3 multiplied by first ordinate plus last ordinate plus 2 into sum of remaining odd ordinates plus 4 into sum of remaining even ordinate. We have to do numbering like this. First offset will be number as 1. So, let us do the numbering of offset. So, offsets given in this particular question can be numbered as O1 2.3, O2 is equal to 3.8, O3 is equal to 4.55, O4 is equal to 4.75, O5 is equal to 5.25, O6 is equal to 7.3, O7 is equal to 8.95, O8 is equal to 8.25, O9 is equal to 5.5. So, what is the length of first offset, which is O1 2.3, length of last offset O9 is 5.5. Remaining odd offset, what are remaining odd offset? O3, O5 and O7. Remaining even offset, which are the remaining even offset? O2, O4, O6. So, when we substitute values in above equation, we will get the figures A is equal to 10 by 3 multiplied by first offset length is 2.3, last offset length is 5.5 plus 2 into sum of remaining odd offsets, which is 4.55 plus 5.25 plus 8.95 plus 4 into sum of remaining even offsets, which is 3.8 plus 4.75 plus 7.3 plus 8.25. When we simplify this equation, we will get A is equal to 10 by 3 multiplied by in the bracket 2.3 plus 5.5 plus 37.5 plus 96.4. So, after the calculation, we will get area as 472.33 square meter. Now, if we will try to solve the same problem with the trapezoidal rule, what is the formula? Formula is area is equal to D by 2 multiplied in the bracket first offset plus last offset plus 2 into sum of remaining offset. First offset is 2.3, last offset is 5.5. So, we have to just substitute the value. D, which is the common distance, is 10 meter, first offset is 2.3, last offset is 5.5 plus 2 into sum of remaining offsets. We have to just sum up all the remaining offsets. So, after simplifying it, we will get A is equal to 10 by 3 multiplied by in the bracket 2.3 plus 5.5 plus 2 into sum of remaining offset is 42.85. So, we will get area as a 467.5 square meter. Now, if we go for the average ordinate rule, what is the basic assumption in average ordinate rule is that the area is calculated by considering the whole area as a rectangle with the length as a length of baseline and the breadth as a average ordinate. So, area will be equal to average ordinate into length of the baseline. How we will calculate average ordinate? It will be sum of ordinate divided by number of ordinate into length of the baseline. So, sum of ordinate, we can substitute the value 2.3 plus 3.8 plus 4.55 plus 4.75 plus 5.25 plus 7.3 plus 8.95 plus 8.25. Number of ordinates are 9, length of the base is 80 meter. So, after doing calculation, we will get area as 450.22 square meter. Now, see the next problem. The following offset were taken from a chain line to an irregular boundary line at an interval of 10 meter. At an interval of 10 meter means D is equal to 10 meter. What are the offset length? 0, 2.5, 3.5, 5, 4.6, 3.2, 0. Compute the area between the chain lines, the irregular boundary line and end of the offset by Simpson rule. So, here we are supposed to calculate the area with the help of Simpson formula. So, we know the formula for the Simpson rule, which is area is equal to D by 3 multiplied in the bracket first offset plus last offset plus 2 into sum of remaining odd ordinates or offset plus 4 into sum of remaining even ordinates or offset. So, let us do the numbering of offset. O1 is equal to 0, O2 is equal to 2.5, O3 is equal to 3.5, O4 is equal to 5, O5 is equal to 4.6, O6 is equal to 3.2, O7 is equal to 0. So, we have to just substitute the values in the formula. We have to substitute value in the above equation. So, we can substitute D is equal to 10 meter. So, A is equal to 10 by 3. The first offset value is 0, last offset value is 0 plus 2 into sum of remaining odd ordinate, which is 3.5 plus 4.6 plus 4 into sum of remaining even ordinate, which is 2.5 plus 5 plus 3.2. So, we can simplify this equation as area is equal to 10 by 3 multiplied in the bracket 0 plus 16.2 plus 42.8. After doing calculation, we will get area as 196.67 square meters. So, this is the answer. Now, the next numerical problem is given. The following offsets were taken from a chain line to a boundary. Distance is given in the meters, offset is also given in the meter. So, at distance 0, offset is 9.4 meter. At distance 30 meter, offset is 10.8 meter. At distance 60 meters, offset is 12.5 meter. At distance 90 meter, offset is 10.5 meter. At distance 120 meter, offset is 14.5 meter. At distance 150 meters, offset is 13 meter. At distance 180 meters, offset is 7.5 meter. Compute the area included between the chain line and the boundary by the Simpson rule. Again, we have to apply the Simpson rule only. So, what is the formula for the Simpson rule? It is the D by 3 into first offset plus last offset plus 2 into sum of remaining odd offset or ordinates plus 4 into sum of remaining even offsets or ordinates. Let us do the numbering of the offset. O1 is equal to 9.4, O2 is equal to 10.8, O3 is equal to 12.5, O4 is equal to 10.5, O5 is equal to 14.5, O6 is equal to 13, O7 is equal to 7.5. So, the first offset is 9.4, last offset is 7.5, remaining odd offset will be O3 12.5, O5 14.5, remaining even offsets or ordinate will be O2 10.8, O4 10.5, O6 13. After substituting the values in the above equation, we will get area is equal to D is 30 meters. So, 30 by 3 multiplied in the bracket 9.4 plus 7.5 plus 2 into 12.5 plus 14.5 plus 4 into 10.8 plus 10.5 plus 13. So, after doing the calculation, we will get the area as 2081 square meter. So, with this we conclude this session. Thank you all for your active participation today. We look forward to discussing the next topic in our upcoming class.